Hello, today I'll be presenting my project assessing spatial patterns of heat vulnerability across Nueces County, Texas, using GIS and spatial statistical analysis. This project integrates land cover and demographic data to identify areas where elevated heat exposure and population concentrations overlap, and then evaluates whether those patterns are spatially clustered throughout the county. Urban heat exposure has become an increasing environmental and public health concern, particularly in rapidly urbanizing environments. Impervious surfaces such as asphalt and concrete absorb and retain heat more efficiently than vegetated landscapes, contributing to the elevated urban temperatures. At the same time, vegetation and tree canopy can help reduce localized temperatures through shading and evapotranspiration. Nueces County presents an interesting study area because it contains a mixture of urban development, industrial infrastructure, coastal environments, and rural landscapes. The study area for this project is Nueces County, Texas, located along the Gulf Coast in South Texas. The county includes the highly urbanized city of Corpus Christi, along with the suburban, industrial, agricultural, and coastal regions. This mixture of landscapes creates varying land cover characteristics and population distributions that influence localized heat exposure patterns. The primary objective of this project was to evaluate spatial patterns of heat vulnerability across Nueces County using GIS-based analysis. Specifically, I developed a land cover-based heat exposure classification, calculated population density using census data, and then combined these variables into a composite vulnerability index. Spatial statistical methods were then used to evaluate clustering patterns and identify statistically significant hotspots of this vulnerability. The two primary data sets that were used in this analysis was first the National Land Cover Database, which is raster data, and was used to represent land cover characteristics and estimate relative heat retention potential. So it's a heat proxy essentially. And then secondly, I used the American Community Survey population data, which was used to calculate the population density at the census tract level. Census tracts served as the primary spatial analysis unit throughout this project. The National Land Cover Database land cover classes were reclassified into a 5-class heat exposure scale, representing relative heat retention potential. So water bodies, wetlands, and densely vegetated areas were assigned lower exposure values due to their cooling characteristics, while highly developed urban surfaces were assigned higher values because of its increased impervious surfaces and reduced vegetation. This workflow illustrates the transition from detailed land cover classes into simplified heat exposure categories used in the vulnerability analysis, and you'll see that here. This is just a video of the reclassification from the raw data into my now reclassified land cover classes of the 5-class heat exposure scale. So population density was calculated by dividing total census tract population by tract land area in square kilometers. Mean heat exposure values were then calculated for each tract using zonal statistics as table. These variables were combined into a composite vulnerability index using a multiplicative relationship, allowing areas with both elevated heat exposure and higher population concentrations to receive higher vulnerability values. The resulting vulnerability index revealed strong spatial variation throughout Nueces County. So the highest vulnerability values were concentrated within the urban core of Corpus Christi, where higher population density coincided with the developed land cover and increased heat exposure potential. In contrast, the rural areas and peripheral regions generally exhibited lower vulnerability values due to lower population density and reduced urban development intensity. And you can see this difference between the dark red and the lighter pale yellow values. From there, Global Moran's eye was used to evaluate whether vulnerability values were spatially clustered or randomly distributed throughout the county. Across all neighborhood definitions tested, Moran's eye values range from approximately 0.58 to 0.66, with z-scores exceeding 13 and p-values below 0.001. These results indicate strong positive spatial autocorrelation, meaning that similar vulnerability values tend to cluster together spatially rather than occurring randomly. And you can see that I tested 3 different neighborhoods. K equals 6 will be all the way to the left, the figure all the way to the left. And then K equals 10 is the figure all the way to the right. From there, I then used JEDIS or GI star analysis, which was conducted to identify statistically significant local clusters of elevated vulnerability. Hotspots were concentrated primarily within the urbanized portions of Corpus Christi, while the cold spots, as you can see, dominated the western and peripheral regions of Nueces County. I also did test 3 different neighborhood sizes, just like I did the Moran's eye. So as neighborhood size increased from K equals 6 to K equals 10, clustering patterns became more spatially generalized. Although the overall spatial distribution remained relatively highly consistent. The first one at the top is the K equals 6, and you can see there's a little bit of the non-significant areas. And then as we increase that neighborhood definition, you can see there's a lot more hotspots that are coming into play that are statistically significant. Overall, the analysis demonstrated strong and statistically significant spatial clustering of vulnerability throughout Nueces County. The urban core consistently exhibited elevated vulnerability, while peripheral regions displayed lower vulnerability patterns. However, several limitations should be acknowledged. The analysis relied on land cover as a proxy for heat exposure rather than using direct temperature measurements. And then additionally, socioeconomic variables could further improve future vulnerability assessments, like using demographic data or more robust demographic data. In conclusion, this project demonstrated that heat vulnerability patterns within Nueces County are highly spatially organized and strongly associated with urban development, intensity, and population concentration. Spatial statistical techniques such as Moran's I and JEDIS or GI star provided effective tools for identifying both regional clustering patterns and localized vulnerability hotspots. These approaches can support future planning efforts aimed at improving heat resilience and reducing environmental vulnerability throughout rapidly developing urban areas such as Corpus or such as Nueces County. So thank you.